Hi guys, myself Rakshita from Sri Venkateshwara College of Engineering, Bengaluru. Let us see the topic of symmetric key distribution using symmetric encryption of subject cryptography. Today we are going to discuss about the topics different techniques of key distribution, how to distribute key between two users, different type of keys, key distribution scenario, hierarchical key control, session key lifetime, a transparent key control scheme, decentralized key control. Let us see more about symmetric key distribution using symmetric encryption. When two parties share the same key, that is symmetric key, that protect from access by others. The process between two parties that exchanges that key called as symmetric key distribution. If two person wants to communicate with each other via messages or exchange data without interference of other. Two parties or person A and B achieve the key distribution in various ways. First one, A can select a key and physically deliver it to the B. A third party can select the key and physically deliver it to the A and B. If A and B have previously and recently used a key, one party can transmit the key to the other, encrypted using the old key. If A and B each has an encrypted connection to a third party C, C can deliver on the encrypted links to A and B. Options 1 and 2 calls for manual delivery of a key to the users. In manual delivery of key is difficult in a wide area distributed system. Returning to our list, option 3 is a possibility of for either link encryption or end-to-end encryption. But if an attacker ever succeeds in gaining access to one key, then all subsequent keys will be revealed. For end-to-end subscription, some variation on option 4 has been widely adopted. In this scheme, a key distribution center responsible for distributing keys to pairs of users, like hosts, processes, applications as needed. Each user must share a unique key with the distribution center for purpose of key distribution. Let us see more about key distribution scenario. The key distribution concept can be deployed in a number of ways. A typical scenario is illustrated in figure. As displayed in an example, it is like initiator A and responder B, with connected to a key distribution center. When a initiator A should need any response, it will give a message to a key distribution center, and the message will be initiated or exchanged between initiator A and responder B. The scenario assumes that each user shares a unique master key with the key distribution center. Let us assume that user A wishes to establish a logical connection with B and requires a one-time session key to protect the data transmitted over the connection. User A has the master key KA known as to itself and the KDC. Similarly, user B shares the master key KB with the KDC. KDC means key distribution center. Let us discuss all the steps. Step 1. A issues a request to the KDC for a session key to protect a logical connection to the B. The message includes the identity of A and B and a unique identifier N1 for this transaction, which we refer to as a none. The nonce may be a timestamp, a counter, or a random number. The minimum requirement is that it differs with each request. Also, to prevent masquerade, it should be difficult for an opponent to guess the nonce. Thus, a random number is a good choice for a nonce. Step 2. The KDC responds with a message encrypted using KA. Thus, A is the only one who can successfully read the message, and A knows that it originated at the KDC. The message includes two items intended for A. The one-time session key KS to be used for the session, the original request message including the nonce to enable A to match the response. With the appropriate request, thus A can verify that its original request was not altered before reception by the KDC and because of the nonce. In addition, the message includes two items intended for B. The one-time session key KS to be used for this session. An identifier of A, example its network address. IDA, these last two items are encrypted with KB. They are to be sent to B to establish the connection and prove A's identity. Step 3. A stores the session key for use in the upcoming sessions and forwards to B the information that originated at the key distribution center for B, namely E. Because this information is encrypted with KB, it is protected from eavesdropping. B now knows the session key KS, knows that the other party is A from DA, and knows that the information originated at key distribution center because it is encrypted using KB. At this point, a session key has been securely delivered to A and B, and they may begin their protected exchange. Step 4. Using the newly minted session key for encryption, B sends a nonce N2 to A and E. E is known as KS and N2. Step 5. Also using KS, A responds with F, where F is a function that performs some transformation on N2. Example adding 1, E. Symmetric key distribution technique using symmetric key encryption. There are four different methods are used: hierarchical key control, session key lifetime, a transparent key control scheme, decentralized key control. Hierarchical key control. It is not necessary to limit the key distribution function to a single key distribution center. Indeed, for very large networks, single KDC is not enough to distribute keys among all users. As an alternative, a hierarchy of KDCs can be established. For example, there can be local KDCs, each responsible for a small domain of the overall internetwork, such as a single LAN or a single building, for communication among entities. Within the same local admin, the local is responsible for the key distribution. If two entities in different domains desire a share key, then the corresponding local KDCs communicate through a global KDC. In this case, any one of the three KDCs involved actually selected the key. The hierarchical key concept can be extended to 3 or even more layers, depending on the size of the number of users and the geographic score of the internetwork. Session key lifetime. The more frequently session keys exchange, the more secure they are, because the attacker has to capture session key every time to decrypt ciphertext. Short session key lifetime, key exchange frequently and more secure. A transparent key control scheme. The steps involved in establishing a connection are shown in the figure. When one host wants to set up a connection to another host, it transmits a connection request packet. The SSM session security module says that the packet applies to the KDC for permission to establish the control. The communication between the SSM and the KDC is encrypted using a master key shared only by this SSM. If the KDC approves the connection request, it generates the session key and delivers it to the two appropriate SSMs. Decentralized key control. Decentralized key control is not practical for larger network using symmetric key encryption only. It may be useful within a local context. A session key may be established within the following sequence of steps. Step 1. A issues a request to B for a session key and includes a N1. B responds. Step 2. B responds with a message that is encrypted using the shared master key. Step 3. Using the new session key, A returns F to B. Thank you.